compound interest. This is the formula for compound interest. In this formula, A is the total amount that you earn after n years. P, the principal or original value. R, the interest rate per annum. N, the number of years the money is invested. Sebastian leaves 3,000 in the bank for 2 years. It earns compound interest of 2% per year. Calculate the total amount Sebastian has in the bank at the end of the years. So in this case, the 3,000 is the amount which is the principal amount that was in the bank, and it had been there for 2 years under the interest rate of 2% per year. They are asking you to calculate the total amount under compound interest. So firstly, we write the formula for compound interest. A equals P 1 plus R over 100 to the power T. And let's substitute the values that is extracted from the sum. Using the calculator, you can get the total amount that is in the bank at the end of 2 years, 3,121.2. Next question. Fiona leaves £1,600 in the bank for 4 years. It earns compound interest of 4% each year. Calculate the total amount Fiona has in the bank at the end of the 4 years. So this is the principal amount 1,600 and the time is for 4 years. The interest rate is 4%. So you are asked to calculate the total amount A. Let's write the formula. A equals P 1 plus R over 100 to the power T. And by substituting the values, we can get the answer as 1,871.77. Next question. Natalie leaves £600 for 2 years at 10% per year compound interest. Let's extract the value P, T, also R, along with they're asking how much interest does she earn. They're not asking for the total amount, but in this case also it is compounded interest, so it is compound interest. We write the same formula. A equals P1 plus R over 100 to the power T. By substituting the values, our total amount is 726. But we don't want to know the total amount. We want to know the interest. So how do you find the interest? We learned this equation, total amount, which is A is equal to P plus I, such that 726 is equal to 600 plus I. I is the initial amount or the principal amount invested. So at the end of 2 years, she has earned a total of 726. This extra 126 is the interest that she has earned. Next question. Jenny invests £4,000 for 2 years at 5% compound interest, paid yearly. Tim says that the interest Jenny will receive will be £40. Is he right? Let us see. So the principal amount is 400 and it had been invested for 2 years, and the compound interest rate is 5%. Whereas Tim says that the interest Jenny will receive will be £40, that is I. Since this is a compound interest question, we are going to use A equals P 1 plus R over 100 to the power T, and let's substitute the values that we extracted from the sum. Such A, the total amount is equal to 441. We want to check for the interest. So the interest is A equals to P plus I, whereas the total amount is 441. Initial amount is 400 plus I. Interest here is £41. So is Tim right? No, he is not right, because he thinks that Jenny will receive £40 only. £5,200 is invested at 2.8% compound interest per annum. How many years will it take for the investment to exceed 7,000? So since this is a compound interest question, the first thing is I will write the compound interest formula. Then I will substitute the values that is extracted from the sum. The principal amount P is 5,200, that's this. 2.8 is the interest rate, which is R. And it had been there for a number of years, which you don't know, that is what you're going to find. And the total amount to exceed 7,000. So before exceeding 7,000, let's see how long will it take for the amount to be 7,000. So I will take 7,000 as the total amount, 5,200 as the principal amount, 2.8 as the interest rate, and I will use a bit of algebra to work out the question. So 7,000 divided by 5,200 equals 1 plus 2.8 over 100 to the power t. Now for you to solve this, you are going to use the log function in your calculator. So using the log function in your calculator, what you do, you put this 1.028. That means when you add 1 to 2.8 over 100, it becomes 1.028. You take your calculator, go to the log option, log this 1.028, you put it as the base. You put it as the base. And 7,000 over 5,200, you put it as the value here. So that is equal to this t. Using the calculator, you can get the answer as 10.76. So approximately it needs 7 years for the investment to, approximately it needs 11 years for the investment to exceed 7,000. This is a past paper question. It says Anya has 3,000 to invest in a savings account for 3 years. She can choose from these two accounts. Account A is not simple interest. The interest is charged on yearly basis separately. Account B is compound interest and the interest is charged 1.3% per year. She chooses the account that will give her more money at the end of the 3 years. Decide which account she chooses and find the amount she will have in her account at the end of 3 years. So before I discuss this question, I prefer you try how to work out the question. I will help you. For account A, it is not simple interest. It is just percentages that you have to calculate separately for each year. But for account B, it is the compound interest formula you have to use for a period of 3 years. So when you work out the question for account A, that is 1.1% of 3,000. So what is 1.1% of 3,000? That is 33. So 33 is the interest earned for 3,000 in the first year. Nextly, it says in the question that 1.2% interest added to end of year 1 total. So in the second year, 1.2% interest is added to the first year total. At the year end, you have 3,033. That is 3,000 plus the interest 33. For this 3,033 only, it will charge this 1.2%. So that is 36.4. Nextly, in the third year, 1.4% interest is added to the total amount at the end of year 2. So for 3,033, you will add 36.4. That adds up to 3,070. So 3,033 plus 36.4, which adds up to 3,070. For that, a 1.4% is charged. That is 43. Now you can see at the end of all 3 years, in account A, she can earn $112.4 of interest only. The interest is $112.4. Now let's calculate for account B, which is compound interest. Principal amount is 3,000 while the interest rate is 1.3. So 1.3 divided by 100 added to 1 to the power 3 multiplied by 3,000. You have to use the calculator and your answer is 3,118.5. This is the total amount, not only the interest. So we know that the interest amount is from the total amount when you subtract the principal amount or the initial amount which you saved or invested. So your interest is 118.5. Now you can clearly see if you put the money into account A, at the end of 3 years you will earn a total of 112.4 interest. But if you save the money in account B, at the end of third year, your earnings would be $118.5. So it is advisable to invest in account B, to save in account B because it gives an higher interest. So with this, I will conclude the compound interest video.